Most developers in the Microsoft ecosystem are still spending their days building screens. They are focused on Canvas apps, navigation panels, and button controls while tying PowerFX formulas to various gallery components. That work is real, it ships to users, and it definitely solves problems. But the platform underneath those screens has been rebuilt, and most people simply haven't noticed it yet. The assumption that low-code always means building a Canvas app is broken. Copilot Studio now owns the logic layer because Microsoft moved their entire center of investment. Developers who don't understand what that shift means will soon find themselves building on the wrong foundation. This episode is about that structural shift rather than the marketing version you see in slide decks. We are looking at what actually changed, why the old model has a flaw baked into it, and what the new architecture looks like at the layer most people are ignoring. If you want to stay ahead of where this platform is actually going instead of just following what was announced last month, hit subscribe. This is the M365 FM podcast. I'm Mirko Peters. Let's get into it. The old model. What low-code development actually was. To understand what is breaking right now, you have to understand what was built and why it made sense at the time. From roughly 2018 through 2024, the M365 developer story had one dominant answer for business automation. That answer was Power Apps Canvas. You had a process that lived in spreadsheets or email, a business user who needed something faster, and a developer who could turn that around in days. That was the value proposition. It was about speed and proximity to the business rather than architectural elegance. And it worked. The alternative back then was a full development project with a team of engineers and a 6-month backlog. Requirements processes often outlasted the original problem, so Canvas apps filled a real gap. They let organizations build real solutions quickly with people who understood the business instead of people who only understood distributed systems. The assumption baked into every Canvas app was simple. Users know what they are looking for. Navigation is the interface. Screens are the solution. You build a form for data entry, a gallery for data display, and a button to trigger a flow. Then you wire it all together with PowerFX. That model is intuitive because it mirrors how people think about software as a collection of pages you move between. Low-code developers were valued for exactly that. They offered speed of delivery and closeness to business users. They had the ability to turn a whiteboard sketch into a working app before the meeting notes were even written up. Architectural depth was never the point. Getting the job done was the only thing that mattered. But there was a structural flaw in that model that nobody talked about much because the apps were small enough that it didn't matter yet. The flaw was this: logic lived on screens. Business rules weren't kept in a logic layer. They were scattered across controls. You had visibility formulas on buttons and validation logic in on-change events. Conditional formatting was tied to variables that were set 3 screens back. If you needed to know what the app actually did under specific conditions, you didn't read a specification. You traced formulas across controls and hoped you hadn't missed one. Every new requirement meant another screen, and that usually meant another set of formulas that partially duplicated what already existed. There was no single source of truth for what the business rules were. The app itself was the documentation. That worked when apps were small. When a department needed one app for one process, a Canvas solution with 15 screens was manageable. A competent developer could hold the whole thing in their head. But organizations grew their app estates and processes got more complex. The same logic needed to work across multiple apps, channels, and devices. Suddenly, the Canvas model didn't just feel stretched. It was actively working against maintainability. Apps with more than 20 or 30 screens became effectively unmaintainable by anyone except the person who built them. Sometimes even the original creator couldn't figure it out 6 months later. The delegation problem made performance unpredictable at scale. Non-delegable queries ran fine in development, but fell apart in production with real data volumes. Logic embedded in UI controls couldn't be shared, reused, or tested in isolation. That model wasn't wrong for what it was solving in 2019. But the platform underneath it has been rebuilt. The rebuild didn't just add features, it changed where logic is supposed to live. The platform shifted. What Microsoft actually changed. Here is what Microsoft actually did, and why it matters more than most people realize. The roadmap pivot isn't speculation. It is documented in release wave announcements, developer tooling decisions, and where the product teams are concentrating engineering resources. Around 2025 and into 2026, the center of innovation at Microsoft moved. It didn't move away from the Power Platform entirely, but it shifted decisively away from Canvas apps as the primary way to build. The new focus is Copilot Studio and declarative agents as the first-class development story for AI-first scenarios. Canvas apps are not deprecated. That needs to be said clearly because the nuance matters. Microsoft is still shipping features for Power Apps, connectors are improving, and the AI-assisted build experience inside the designer is getting better. Canvas is not going away, but still supported, and where new investment is concentrated are two different things. Confusing them is how you end up optimizing for a layer the platform is moving past. The signal is in the tooling. Microsoft released the M365 Agent Toolkit, which is a Visual Studio Code extension purpose-built for creating, deploying, and publishing agents directly into Microsoft 365 Copilot. That toolkit covers agent creation, packaging, provisioning, testing, debugging, and store publication. It is a full development lifecycle, and it is built around agents instead of apps. When a platform ships a dedicated toolkit for a new paradigm, that is not just a feature announcement. It is a statement about where the developer story is heading. The declarative agent model is worth pausing on because it is architecturally different from everything that came before it. When you build a declarative agent, you are not writing imperative code. You are writing instructions. You define who the agent is, what it knows, what it can do, and how it should behave in JSON, manifests, and instruction files. Copilot handles the reasoning, the orchestration, the memory, and the scaling. You are describing outcomes rather than programming steps. In the March of 2026 Microsoft 365 and Power Platform community call, Microsoft described it directly. They said you do not write code when building declarative agents, you write instructions. That is not a simplification for beginners. That is the architectural model. The logic layer is no longer something you wire together manually. It is something you configure, constrain, and govern. What that means structurally is that the app as a visual container is losing its role as the primary front door for enterprise interactions. Microsoft is positioning Copilot as the universal client. Users start with intent rather than navigation. They do not open an app and look for the right screen, but instead they express a goal and the system figures out how to fulfill it. The Canvas model assumed users would navigate to what they needed. The agentic model assumes users will describe what they need and the system will decide what to do next. This is not a cosmetic change. It is a change in where decision-making authority lives in the architecture. In the Canvas model, the developer made the decisions about what screens exist, what paths users can take, and what happens when a condition is met. In the agentic model, the agent makes those decisions at runtime, constrained by the instructions and governance rules the architect defined. The developer's job shifts from building the decision tree to designing the boundaries within which the agent operates. That shift has implications for what skills matter, what roles get hired, and what kind of work survives automation. But before we get there, we need to understand exactly what Copilot Studio is. There is a widespread misconception about it that is causing teams to underinvest in the right places. Most people think of it as a chatbot builder. That is the wrong mental model, and it is leading to the wrong architecture decisions. Copilot Studio is not a chatbot, the reasoning layer explained. Let's deal with the misconception directly because it is the most expensive mistake teams make when they first encounter Copilot Studio. The assumption most people bring to it is that it is a fancier bot builder. They see it as a low-code wrapper around a language model. It might be a step up from Power Virtual Agents, but they think it is fundamentally the same category of thing. They view it as a conversational interface. You bolt onto an existing process so users can ask questions instead of clicking buttons. That framing is wrong. Building on it produces architecture that will fail at scale. Copilot Studio is a goal-driven orchestration engine. The distinction is not cosmetic. A chatbot receives a message and returns a response. Copilot Studio receives a goal expressed as natural language, a structured input, or an event trigger, and then it decides what needs to happen to fulfill it. It interprets intent. It selects the right tools from the set available to it. It executes across systems. It evaluates whether the result actually addressed the goal. If something changes or fails mid-execution, it adapts. That is a fundamentally different thing from a bot. The clearest way to see the difference is to compare it directly with Power Automate. When you build a flow in Power Automate, you are the one making every decision. You decide the trigger, you define every branch, and you specify the exact sequence of actions. The flow executes exactly what you built in the order you defined it every single time. It does not interpret, it does not evaluate, it runs the steps you wrote. Copilot Studio agents do not run your steps, they decide which steps to run. You provide instructions that describe the goal, the constraints, the available tools, and the acceptable behaviors. The agent reasons over those instructions at runtime and determines what to do based on the context it is operating in. Two requests that look similar on the surface might result in completely different action sequences because the context is different. This is not a subtle difference in implementation. It is a different execution model. The implication for business logic is significant. In the Canvas app model, business logic was encoded in formulas and flows, which was explicit, imperative, and manual. You wrote what happened. In the agentic model, business logic is encoded in instructions, tool configurations, and orchestration rules. The agent interprets those rules and applies them dynamically. Logic does not live in a specific formula on a specific screen. It lives in the system-level definition of what the agent is allowed to do, what it knows, and what outcomes it is trying to achieve. That is a harder thing to build correctly. It requires a different kind of thinking. You aren't asking what steps happen in what order, but rather what constraints and goals define correct behavior across all possible inputs. That shift from procedural to declarative logic design is exactly why the skills needed to work effectively with Copilot Studio are different from the skills that made someone effective in Power Apps. One more thing worth being precise about, because it comes up constantly in team discussions, is that Copilot Studio is not a wrapper for a public language model. The agents you build in Copilot Studio run against enterprise data under enterprise permissions inside the Microsoft 365 security boundary. They can be grounded on SharePoint content, Dataverse records, external APIs, and knowledge bases that you define. The reasoning happens inside a governed environment, not on top of a public API. That distinction matters enormously for compliance, for data handling, and for what kinds of use cases are actually viable in regulated industries. So when someone in your organization says, we should build a Copilot Studio agent for this, the question to ask is not what the bot should say. The question is what goal we are giving the agent, what tools we want it to use, and what constraints we need to put around its decision-making. That is an architecture question. It is not a UX question. And that brings us to the mental model that once you have it, reframes almost every decision you will make on this platform. Judgment versus logic, the architectural split that changes everything. Think of this as your new mental model. You need to hold on to this one because it reframes every single architecture decision you will make on this platform from here on out. In any automated system, you are dealing with two fundamentally different types of work. There is judgment, which is the act of deciding what should happen, and then there is logic, which is the act of making it happen. These two forces have always existed inside every piece of software ever built, but something has changed. We finally have a platform where these two things can be handled by completely different layers, and each layer is optimized for its own specific job. Power Automate owns the logic. This isn't a limitation of the tool. It is a core design principle. When your input is structured, your rules are set in stone, and your volume is high, Power Automate is the right choice. You use it when the output needs to be auditable and reproducible every single time. It runs the exact same steps in the exact same way, which is not a weakness. In fact, that is exactly what you want when you are provisioning accounts, assigning licenses, or routing approvals. Deterministic processes require deterministic engines to stay reliable. Copilot Studio, on the other hand, owns the judgment. This is the territory of the agent. You use it when the input is messy, or the right action depends on context that you can't reduce to a simple if-then rule. It is built to reason across multiple data sources and adapt based on what it finds. Think about exception handling, dynamic routing, or requests that arrive in natural language with half the information missing. That kind of work breaks a Power Automate flow because flows weren't designed to think. They were designed to execute decisions that a human already made, whereas the agent is the thing actually making the decision. The mistake most teams make is using Power Automate for judgment calls, and it ends up being a very expensive error. You have probably seen this yourself. It starts with a flow that has 15 nested conditions branching across every edge case the developer could imagine. Then, after the flow goes live, a dozen more cases get bolted on. Every new exception adds a new branch, and every branch adds more surface area to maintain. What started as clean automation turns into a fragile decision tree that snaps the moment reality doesn't match a condition written 6 months ago. That is what happens when you force judgment work through a logic engine. The other mistake is less common, but it is actually more dangerous. This is when people use Copilot Studio for work that requires exact 100% reproducibility. If you are running a process where the output must be identical every time, like a financial calculation or a compliance check, you do not want an agent making that call. Probabilistic reasoning has no business being inside a deterministic process. The risk of a hallucination isn't just a theory in these cases. It is a design flaw that is waiting to surface in your production environment. A healthy architecture keeps these layers clean and explicit. The agent handles what should happen, while the flows handle how it happens. The agent receives a goal, reasons through the data, determines the right move, and then calls the flow to execute it. The flow doesn't decide anything. It simply does what it is told, reliably and at scale. The agent doesn't execute the individual steps. It orchestrates which steps get executed and when they need to happen. This isn't just a theory. This is the exact pattern that Microsoft and enterprise architects are moving toward right now. If you look at the technical guidance coming from Microsoft, or the patterns used by the partner community, or the architecture reviews of companies running real agentic workflows, they all land in the same place. The agent acts as the reasoning layer, and the flow acts as the execution layer. There is a clean, hard line between the two. Once you see the split, the flaws of the old model become obvious. The old Canvas app model collapsed judgment and logic into the same place, which was the screen. PowerFX formulas were trying to do both at once. They were deciding what should happen and making it happen inside a single UI control. That is why Canvas apps became impossible to maintain at scale. It wasn't because PowerFX was a bad language. It was because putting judgment and logic in the same place means you can't change one without breaking the other. You can't govern the decisions independently from the execution, and you certainly can't reuse those layers in other systems. The agentic architecture does more than just change your tools. It finally fixes a structural problem that has been there from the beginning, where Canvas apps were actually breaking. We need to get specific about how these systems fail, because saying Canvas apps don't scale is too vague to be helpful. The failure isn't a random event. It follows a very predictable pattern that anyone working on a mature Power Platform estate has seen 100 times. It usually starts with the duplication problem. When your business logic lives inside a button or a gallery on a screen, it doesn't get reused. it gets copied. A validation rule on screen 4 gets rebuilt on screen 11 because the developer didn't know the first one existed or they couldn't get to it easily. Maybe they just needed a slightly different version and it felt faster to write it from scratch than to try and abstract the original. When you multiply that across an estate with dozens of apps built by different people over several years, you don't have a cohesive system. You have a pile of independent copies of business rules that are all slowly diverging from each other. When a business rule eventually changes, every single one of those copies has to be found and updated manually. Some of them always get missed. The ones that are forgotten create inconsistencies that stay hidden until they turn into errors in production. Usually, you find them during an audit or a process handoff where one app produces an output that the next app doesn't recognize. Then you hit the performance cliff. Canvas apps look great in a dev environment with a few dozen test records, but they degrade fast when they hit real-world data volumes. This is the delegation problem. When you use a non-delegable function, the app has to pull records down to the user's device and filter them there instead of letting the database do the work. At a small scale, you won't even notice the lag. At an enterprise scale where you are dealing with SharePoint lists or Dataverse tables with hundreds of thousands of rows, you end up loading thousands of records just to show 10. The performance tanks, the users complain, and developers start adding hacks that make the logic even harder to read. The governance problem is even deeper than the technical issues. When your logic lives inside a UI, the only thing you can really govern is who has access to that UI. You can control who opens the app, but you can't easily govern the business decisions the app makes once a user is inside. There is no separation between who can use the tool and what the tool actually does. The decision logic and the access control are fused into the same file. That might be fine for a simple calculator, but it is a massive compliance nightmare for anything involving regulated data or audit requirements. Many organizations learned this lesson the hard way when they tried to move their apps to new channels. They wanted a mobile version of a desktop app, or a Teams integration, or a portal for their customers. Every time they expanded, they had to rebuild the logic layer from scratch because that logic wasn't portable. It was stuck inside the controls of a specific screen layout. You couldn't just lift the business rules out and put them somewhere else because they were inseparable from the UI. This is the honest truth about what the Canvas era gave us. It solved the delivery problem. Companies that used to wait years for IT to build a basic tool were suddenly getting those tools in a matter of weeks. That provided real value, and we shouldn't ignore that success. But the same choice that made Canvas apps fast to build, putting logic directly into the presentation layer, is exactly what made them expensive to maintain. It made them impossible to govern at the rule level and kept them from being reused in different contexts. That technical debt didn't appear on day one. It grew quietly for years, and now many organizations are stuck with app estates where the business logic is scattered across thousands of formulas. It is trapped inside UI controls with no way to get it out other than rebuilding the whole thing from the ground up. The agentic model is more than just a better way to build a front end. It provides a completely different answer to the question of where logic should live, and that answer changes everything about how we build for the future. How agentic logic works inside the orchestration engine. So what actually happens when a Copilot Studio agent receives a goal? I'm not talking about the marketing version, I am talking about the mechanical version. Once you understand the sequence, every architectural decision you make downstream starts to make obvious sense. It starts with intent interpretation. The agent receives an input, which might be natural language from a user, a structured payload from an event, or an email passed by a connector. But that input is rarely clean. It is often incomplete or ambiguous. If a user says, "Help me onboard the new contractor starting Monday," that is not a structured API call. It is a goal filled with missing fields and implied dependencies. The agent has to figure out what is actually being asked, what information is missing, and what it already knows from the context. Once the intent is clear enough to act on, the agent selects its tools. This is where it diverges sharply from the old world of Canvas apps. The agent does not follow a predefined path. It looks at everything available to it: Power Automate flows, connectors, knowledge sources, and other agents, and then it decides which ones are relevant. It chooses the order and the parameters at runtime based on the specific situation. If you give the same agent a similar request but change the context, it might take a completely different sequence of actions and still be correct. Execution follows selection, but execution is not the end of the loop. After the agent calls a tool and gets a result, it evaluates whether that result actually moves the needle. If a flow returns an error, the agent does not just fail silently. It can retry with different parameters, escalate to a human, or surface the failure with enough detail for a person to fix it. This adaptive loop is what makes agents genuinely different from standard flows. A flow fails at the step where the error occurred and stops, but an agent fails and asks what to do next. Multi-step orchestration is where this gets interesting for the enterprise. A single goal might trigger a sequence that spans 5 different systems, involves waiting for an approval, and then resumes once that approval is granted. The agent holds the state of the overall goal across every one of those steps. It knows what has been finished, what is still pending, and what the next move should be. Building that kind of stateful orchestration used to require massive custom development, but in the agentic model, it is just a design choice in how you configure behavior. Now, I want to be precise about a distinction that causes a lot of confusion. There are agent flows and there are cloud flows, and they are not the same thing even though they share the same engine. A cloud flow in Power Automate is a general purpose tool. It runs under Power Automate licensing, it is accessible across the whole platform, and it is designed for predictable standalone processes. An agent flow is different. It is a flow that has been converted to run inside Copilot Studio capacity specifically for agent-driven execution. It runs under the Copilot Studio licensing model, which means it consumes message capacity rather than flow entitlements. And here's the kicker. Once you convert a flow to an agent flow, you cannot convert it back. That is not just a technicality, it is an architectural commitment. When you turn something into an agent flow, you are stating that this logic exists to serve the agent, not to run on its own. It is a tool the agent calls, not a process that stands alone. Keeping this distinction clear prevents a whole category of problems around licensing and governance that teams run into when they start mixing the two without a plan. The agent owns the what and the when, the flow owns the how. This separation is what makes the system maintainable as it grows. It is the exact opposite of how we used to build Canvas apps, where everything lived in the same messy layer with no separation at all. But this architecture has a constraint that most teams do not discover until they hit it in production. And when they hit it, it is frustrating, because nothing in the documentation prepares you for it. The safety summarization problem, what agentic AI hides from you. Here is the constraint. And it is a real one. When you build a multi-agent architecture, a master agent coordinating specialized sub-agents, you run into a wall that isn't mentioned in the brochures. The master agent does not receive the full raw response from a sub-agent. It receives a summarized version, a safe version. Citations get stripped out and document links often disappear. The raw payload from the sub-agent gets processed through an orchestration layer before it ever reaches the master, and that processing is very opinionated. You might write an instruction that says, return the exact response from the sub-agent including all source links, but that instruction will frequently be ignored. This isn't because the agent is broken. It is because the orchestration layer has its own policies about what it passes upstream, and those policies take precedence over whatever you put in your prompt. To be clear, this is not a bug. This is a deliberate safety and compliance behavior. The orchestration layer sanitizes responses to prevent things like prompt injection from moving through an agent chain. It stops a sub-agent's output from becoming a vector to manipulate the master agent. Microsoft is working on improving this fidelity over time, but as of today, this is the reality of the platform. The architectural implication here is massive. You cannot rely on agent-to-agent orchestration if data fidelity is a hard requirement. If your use case needs the user to see specific document citations, exact URLs, or raw API payloads, the direct orchestration path will let you down. If you build on that assumption, you will discover the problem during a high-stakes demo rather than a design review. The workaround exists, and once you know it, it becomes a standard pattern. Instead of calling the sub-agent directly and hoping the response survives, you expose that logic as an API. You build a Power Automate flow with an HTTP trigger that calls your system or knowledge source. That flow aggregates the raw response, keeps all the links and citations intact, and returns it in a structured format the master agent can use. The flow acts as a bridge that preserves the data fidelity that the agent-to-agent channel would otherwise scrub away. This is a more complex way to build. It requires you to treat the flow as an explicit data contract rather than just a background task. But it is also more governable and much easier to test. You can see exactly what the flow returned, you can version the schema, and you can monitor the call independently from the agent's reasoning loop. This is the kind of constraint that separates an architect who has actually built these systems from someone who has only read the manual. The documentation tells you what the platform can do, but experience teaches you where the gaps are and how to navigate around them. Every platform has these kinds of hidden rules. The question is not whether they exist, because they always do. The real question is whether someone on your team knows where the landmines are before you build a production system on top of them. That person, the one who maps the constraints and designs around them, is exactly who the next shift in technology is looking for. The role that is actually growing. From maker to logic architect, the job title is shifting, but the demand underneath it is accelerating. And the direction it's moving is worth paying close attention to, because it tells you exactly where the authority is consolidating in this ecosystem. Organizations aren't looking for more screen builders. They're looking for people who can design systems. They want people who can look at a business problem and produce a solution architecture. Not just an app, not just a flow, but a layered design that specifies which component owns which decision, how data moves between layers, where governance applies, and what happens when something fails. That's a different scope of work than delivering a Canvas app, and it's the scope that's commanding the highest attention in hiring right now. The 2026 M365 Architect job description makes this explicit. Copilot governance is listed as a required competency in postings that 2 years ago wouldn't have mentioned AI at all. AI Foundry integration, agentic workflow design, and responsible AI frameworks are showing up alongside the traditional Exchange Online and SharePoint architecture work. One posting from a major university lists AB 900. Microsoft 365 Copilot and Agent Administration Fundamentals as a preferred certification. That certification didn't exist a few years ago, and the fact that it's now appearing in job requirements is a signal about which layer of the stack employers are prioritizing. The skills that matter now are architectural in nature, API thinking. Not just knowing how to call a connector, but understanding what an API contract means, what happens when it changes, and how to design systems that don't break when the underlying service evolves. State management. Understanding how to design a system that maintains context across a long-running, multi-step process without that context getting corrupted or lost. Data governance. Not at the who has access to this app level, but at the level of data quality, lineage, classification, and what it means when an agent retrieves a document with a sensitivity label attached. Separation of concerns, which we've been discussing throughout this episode in the form of judgment versus logic, and human-in-the-loop design. Building systems where AI outputs feed into human decision points that are explicit, auditable, and recoverable. The skills that are declining in value are the ones that were central to the Canvas era. Pixel-perfect UI design matters less when Copilot is generating the interface. Deep PowerFX formula expertise matters less when the logic layer is moving out of the screen and into agent instructions. Canvas screen navigation logic. Knowing how to wire gallery selections into context variables across 15 screens is valuable in a world where screens are the primary interaction model. It's less valuable in a world where users are expressing goals in natural language and the agent is deciding what to surface. That's not a dismissal of those skills. It's a recognition that their relative weight in the value stack is shifting. Someone who only knows how to build Canvas apps is in a narrower position than they were 3 years ago. Someone who understands both. Who can build a clean Power Apps UI when that's the right answer and design the orchestration layer when that's the right answer, is in a stronger position than either specialist alone. That's the T-shaped profile the market is rewarding. Deep expertise in one layer, with enough fluency in the adjacent layers to collaborate, make architectural trade-offs, and communicate across disciplines. A logic architect who understands enough about UI to know when to hand off to a Canvas component. A UI developer who understands enough about orchestration to know where the boundaries of their responsibility should end. The salary data reflects this directly. AI architects in mature markets command $150,000 to $330,000 and above. Pure low-code specialists, even experienced ones, cluster significantly below that range. The gap isn't about coding ability, it's about scope. The architect is responsible for the behavior of a system across all conditions. The screen builder is responsible for the behavior of a UI in the happy path. The transition from one to the other isn't about learning harder things. It's about expanding what you consider to be within your remit, from delivering an application to governing the logic that runs beneath it. The skill gap is real, what low-code developers are actually missing. So if the role is expanding towards system-level design, the natural next question is, what specifically is missing? Not in the abstract, in practice. What does a capable, experienced low-code developer not know that an AI architect needs to know? The gap is not visual development skill. That's not what's holding anyone back. The gap is architectural depth across 5 specific areas, and being precise about where the gaps actually are matters, because the upskilling path looks very different depending on which ones you're addressing. The first gap is data governance. Low-code developers work with data as an input to a workflow. Data comes in, something happens, data goes out. That mental model works fine when the data is well-structured, clean, and governed upstream by someone else. But AI systems don't just consume data, they reason about it. They retrieve it from unstructured sources. They synthesize it across documents with different provenance. They produce outputs that inherit the quality of the inputs. An AI architect has to think about data quality before it enters the system, about lineage, where the data came from and whether that origin matters for how it should be used. And about drift, which is what happens when the data the system was designed around stops reflecting the data it's actually operating on. That's a different relationship to data than connector-based integration requires. The second gap is model evaluation. A low-code developer knows whether a process works. Does the flow run? Does the form submit? Does the output land in the right place? That's functional correctness, and it's the right standard for deterministic systems. But AI systems aren't deterministic. The question isn't just, did it run? It's, is it accurate, and is it consistently accurate across the range of inputs it will encounter in production? Is it producing safe outputs? Is it stable when conditions shift? Evaluating those things requires a different frame than functional testing. It requires defining what good looks like probabilistically, running structured evaluations against that definition, and monitoring for degradation over time. Most low-code developers have never had to think in those terms, because the systems they built didn't require it. The third gap is human-in-the-loop design. When you build a deterministic system, failure modes are predictable enough that you can handle most of them in the flow itself. retry branch fail with a message. AI systems fail in less predictable ways. The output might be technically complete, but wrong in context. It might be accurate 95% of the time and badly wrong 5% of the time. And both cases look identical to the system. Designing the escalation paths, the approval checkpoints, and the fallback behaviors that make an AI system safe to operate at scale. Those need to be explicit design decisions, not afterthoughts. Low-code developers haven't had to design for probabilistic failure before. Now they do. The fourth gap is integration architecture depth. Calling a connector and designing an integration are not the same thing. RAG pipelines, vector databases, identity-aware retrieval, observability tooling, permission-filtered search. These require understanding what's happening under the abstraction layer, not just how to configure the surface. When something breaks in a connector-based integration, you fix the connector. When something breaks in a RAG pipeline, you need to know whether the problem is in the chunking strategy, the retrieval configuration, the permission mapping, or the prompt. That diagnostic depth requires technical fluency that most connector-based development simply doesn't build. The fifth gap is AI risk management. Understanding what can go wrong with an AI system in ways that have no equivalent in traditional automation. Prompt injection, retrieval poisoning. Agents acquiring permissions that weren't intentionally granted because of a misconfigured scope. These aren't hypothetical. They're documented risks in production deployments. Here's the honest framing though. Low-code developers already have the two things that take the longest to develop: business process fluency and delivery speed. The gaps are real, but they're addable. The foundation is already there. The upskilling path from screen builder to AI orchestrator. Knowing the gaps exist doesn't close them. We need to talk about the actual path forward, because in this transition, the sequence of what you learn matters just as much as the content itself. If you jump straight into governance frameworks before you understand why AI systems behave the way they do, you'll run into a familiar wall. It is the same mistake as building an app before you understand the business process. You end up assembling a system whose failure modes you simply cannot predict. Stage 1 focuses on AI and systems foundations. This isn't about model training or deep data science. Your goal here is to move from simply calling an AI API to truly understanding how these systems behave when they fail. It is a narrower target than it sounds, and you can reach it without a background in machine learning. You need to internalize how language models work at the operational level. You need to know what happens when you exceed a context window, or why retrieval behavior changes when the index shifts. You don't need to master the math, but you do need to understand the behavior well enough to design around the constraints. This takes a few months of deliberate experimentation, and it serves as the foundation for everything else. Stage 2 runs in parallel with the first stage, focusing on the basics of data and cloud architecture. The objective is to understand what lives under your low-code apps instead of just what connects to them. You should know where Dataverse actually stores information and what a storage tier decision does to your retrieval speed. Understanding the difference between structured and unstructured data at the architecture level is vital when you are designing what a RAG pipeline retrieves. You aren't trying to become a data engineer, but you need enough fluency to have an informed conversation with one. This helps you recognize when a problem in an agent's behavior is actually a data issue dressed up as a prompt problem. Stage 3 is where the identity shift happens as you move from app builder to solution architect. This is the transition from designing inside a single platform to designing across an entire ecosystem. You start asking what the end-to-end solution looks like and which layer owns which specific decision. You have to decide when Dataverse makes more sense than SharePoint, or when a flow should be replaced by a function app. At this level, you start producing architecture artifacts like sequence diagrams and solution blueprints that someone else could implement without you in the room. Your portfolio shouldn't be a collection of apps you built, but a collection of architectures you designed. This proves you can think at the system level rather than just the screen level. Stage 4 is about learning just enough code, specifically Python, because that is what the AI tooling ecosystem runs on. You aren't trying to become a full-stack developer. You are learning to call APIs, orchestrate workflows, and write data transformations. The point is to remove the ceiling on what you can understand and design. When you can read a Python script that calls the Azure OpenAI API, you can finally have a real conversation with the engineers building the backend. If you can write a basic script, you can prototype an integration pattern before committing to a full build. That design credibility is worth far more than the lines of code themselves. Stage 5 is where real authority consolidates in AI governance and leadership. This isn't just about knowing the frameworks. It is about being the person who can run a design review and communicate technical risk to stakeholders who don't code. You become the one who defines the policies that constrain agent behavior and takes accountability for system-level outcomes. This is a leadership position that you build over time through experience rather than acquiring it from a single course. One thing I want to say directly is that your portfolio matters more than any certification. A reference architecture showing how an agent, a flow, and a Canvas app work together is worth more in a job interview than a digital badge. Build the artifact and write the record explaining why you made those specific choices. That document is the proof of architectural thinking that a standard resume can never convey. What governance actually means now, the new core skill. In most organizations, governance is treated like a compliance function or a boring checklist you run through right before a project goes live. It is usually a set of policies maintained by IT in a document that nobody actually reads until something breaks. That framing made sense when systems were deterministic and followed the exact steps a developer encoded into them. But that model doesn't work for agentic systems. The architects who understand why it fails are the ones building real authority right now. Governance for agents is a design discipline, not an audit function or a post-build review. You have to embed it into the architecture from the very first conversation about what the agent is supposed to do. The decisions you make early on regarding what an agent can access and how it escalates will define the risk surface for the life of the system. You cannot simply retrofit governance onto an agent that was built without it. If you try, you usually end up having to redesign the whole thing from scratch. Microsoft breaks this down into a 5-phase lifecycle that helps an architect focus their attention. Discovery and planning is where you define the use cases and risk posture before anyone writes a single line of code. Architecture and design is where you decide on the environment strategy and the identity model. During build and integration, you configure the connectors and authentication patterns using the principle of least privilege. Testing and deployment is where you validate security and compliance before anything reaches production. Finally, monitoring and optimization involves the ongoing work of catching drift and retiring agents that no longer serve a purpose. That last phase is the one most teams skip, which leads to the specific problem of ownerless agents. When the person who built an agent leaves the company, the agent stays behind in the tenant. It remains connected to data sources and authorized to act, but no one is accountable for what it does. At a small scale, this is just a nuisance, but at an enterprise scale, it is a massive security incident waiting to happen. Ownership assignment and decommissioning policies are not optional features for a mature model. They are the minimum structure required for a fleet of agents that will likely outlive the people who created them. A risk-tiered model makes this governance actually workable because not every agent needs the same level of scrutiny. A personal assistant agent that only looks at a single SharePoint site for one user carries very little risk. A customer-facing agent that can update financial records or access HR data is a completely different category of system. Using a green, yellow, and red zone framing allows you to map controls to the actual risk level. You can have lighter approval requirements for low-stakes experiments while keeping strict change control for enterprise-critical deployments. This proportionality ensures that governance acts as an enabler instead of a bottleneck. The expanded data loss prevention surface is something most teams don't account for until they are already deep into the build. In the past, DLP policies in the Power Platform focused mostly on which services could exchange data with each other. In an agentic model, that surface grows much larger because DLP now applies to agent connectors and knowledge sources. If an agent is grounded on a SharePoint site or calls an external API, it is subject to these policies. The control surface has expanded, and your governance model has to expand with it to stay coherent. By the year 2026, a center of excellence will look very different than it does today. It won't just be an inventory of apps and flows. It will include agent inventories, evaluation frameworks for safety, and prompt libraries with approved patterns. You will see lifecycle pipelines that move agents into production with the same rigor used for professional software. The architect who owns this model isn't just doing compliance work. They are designing the specific conditions that allow an organization to scale these systems without losing control. That is infrastructure level authority. When something goes wrong at 2 a.m., the company doesn't call the person who built the agent. They call the person who designed the system that governs it. Scaling agentic workflows. What enterprise adoption actually looks like. The shift from theoretical architecture to production deployment is where the real picture emerges. We aren't talking about the polished version you hear in a conference talk, but the version where organizations actually commit budget and assign ownership. This is where teams find out exactly what breaks when agent-driven systems meet real data and real users at scale. By 2026, about 25% of large enterprises are actively deploying agentic AI in their production workflows. This puts us squarely in the early majority phase of adoption, meaning we are no longer on the bleeding edge. There are real case studies to study and real failure modes to learn from, even if most organizations don't have a mature playbook yet. The companies moving right now are building the patterns that everyone else will follow in 18 to 24 months, and that gap is closing much faster than most teams realize. The pattern of adoption stays remarkably consistent across different industries and geographies. Organizations don't start with their most complex or highest stakes processes because the risk is too high. Instead, they focus on high-volume, semi-structured work where the cost of an error is recoverable and the time savings are visible enough to justify the governance investment. IT service triage is the most common first deployment, where agents receive incident reports and gather diagnostic context before routing the ticket to the right team without a human ever touching the first 3 steps. HR policy Q&A is another popular choice, as grounding an agent on actual policy documents allows employees to get accurate answers without burdening the HR team with repetitive questions. Customer support routing and procurement request intake follow this same pattern of high volume and clear business rules to drive meaningful cost reduction. What these use cases share is a strategy that starts with reading and classifying before moving to writing and acting. The sequencing isn't accidental, but reflects a scaling principle that experienced architects apply deliberately to every project. You earn the right to take actions by first demonstrating that your agents understand the domain correctly. An agent that reads invoices and flags exceptions can be validated against human judgment before it ever receives the authority to approve or reject a payment. Starting with a read-only scope lets you build confidence in the reasoning of the system before you extend its power. The multi-agent pattern is emerging as the natural architecture for anything beyond simple triage. A master agent coordinates specialized sub-agents, with one focused on policy retrieval and another on system actions or approval routing. Each sub-agent operates with a defined scope and a governed connector set, while the master agent handles the intent and orchestration. This separation keeps individual agents small enough to evaluate and govern effectively, which allows the overall system to handle complexity that a single monolithic agent simply couldn't manage reliably. The biggest obstacles to scale aren't technical, because the technology is already capable of handling the use cases organizations are deploying. The real hurdles are data readiness, change management, and governance maturity, and they usually appear in that specific order. Agents are only as useful as the quality of the data they can reach, and organizations that built messy SharePoint environments over the years are discovering that grounding an agent on poorly organized content produces poorly organized answers. The governance work that should have happened 5 years ago has become a prerequisite for adoption rather than a background task. Change management is the friction point that most technology-focused teams underestimate during a rollout. Users who have spent years learning to navigate specific apps often resist the shift to expressing intent conversationally. This isn't because the agent interface is worse, but because unfamiliar tools feel slower until the user builds a new habit. The organizations moving fastest on adoption are the ones investing in enablement alongside architecture, rather than treating the human side of the equation as something that happens after the technical build is finished. Organizations that already standardized on M365 and Azure are consolidating their agentic infrastructure on Copilot Studio as the central orchestration layer. The integrations that would take weeks of work for anyone else are already present in the stack. The identity model, the security framework, and the Dataverse substrate are all there and ready to use. And this means the architecture decisions being made inside those organizations right now are establishing the foundation for everything that scales from here. Power Apps is not dead, where UI still wins. Before this episode creates the wrong impression, we need to be direct about one thing. The argument here is not that Canvas apps should be replaced with agents everywhere. That would be a massive overcorrection, and it is just as wrong as pretending that nothing in the industry has changed. A 2026 community survey of about 380 Power Platform practitioners found that 88% plan to build the same number or more Canvas apps that year compared to 2025. For organizations with over 25,000 employees, 64% expected their Canvas app usage to increase. Those aren't the numbers of a dying technology, but the numbers of a mature one finding its right level of use in a changing ecosystem. So where does a traditional UI still win? We can look at a few concrete examples. Complex multi-step forms with strict validation logic are still better suited for apps. When a user needs to enter data across a structured process, like a procurement request with conditional fields or a safety inspection with mandatory photo capture, a Canvas app handles the job better than a conversational interface. The agent asks questions, but the form enforces rules. Those are two different jobs, and when enforcement matters more than flexibility, the form wins every time. Offline scenarios are another area where agents struggle. Agents require a constant connection to reason and process information, but Power Apps can operate against locally cached data and sync when a connection is restored. Field workers, warehouse staff, and technicians in environments with unreliable signals need an interface that works regardless of what the network is doing. No amount of clever conversational design solves that problem, making offline capability a Canvas strength that agents simply don't have. Specialized device integration remains a major factor as well. Camera access for document capture, barcode scanning, signature collection, and GPS for location tagging are all built into the Canvas app model. These integrations work reliably across mobile platforms, and while agents can receive the output of these interactions, they cannot replace the interaction itself. Dense data grids with complex navigation also favor a visual interface. When a user needs to review 200 records, apply filters, and act on them in a batch, a Canvas app or model-driven interface handles that workflow far more efficiently than a conversation. Some work is inherently visual and spatial in nature. Trying to express that work as a dialogue creates friction that doesn't exist on a well-designed screen. The hybrid pattern emerging in mature deployments reflects this reality honestly. Copilot Studio handles the discovery, triage, and routing at the front of the interaction where intent is ambiguous. Power Apps handles the structured completion at the back of the interaction where precision and user control matter most. The agent gets the user to the right place with the right context preloaded, and then the Canvas app closes the transaction correctly. Model-driven apps are finding a similar positioning shift as they become the operator console for agentic systems. This is the interface where someone configures agent behavior, reviews what an agent decided, and manages the data layer that agents read from. It isn't the front door for end users anymore, but the control surface for the people responsible for what the system actually does. The mistake to avoid is the reflexive replacement of every Canvas app with a chatbot just because conversational interfaces feel more modern. Conversational interfaces are not inherently better, as they are great for some things and much worse for others. An interface that makes a knowledge retrieval task effortless can make a dense data entry task feel exhausting. The right question has never been whether to use a Canvas app or an agent. It has always been the same question we've been building toward throughout this episode. We have to decide which layer should own the decision and which layer should execute the steps. The hybrid architecture in practice, how the layers actually work together. Let's make this concrete. Instead of looking at a whiteboard diagram, we should trace an actual architecture from the first click to the final audit log. HR onboarding is the perfect example because it touches every single layer we have discussed. You have conversational intake, structured data, approval routing, and provisioning actions all happening at once. On top of that, you need governance controls that manage everything simultaneously. Imagine this scenario. A hiring manager needs to onboard a new contractor who starts in 2 weeks, so they send that request through Teams. The agent picks it up immediately. The first thing the agent does is figure out what the manager actually needs. A new contractor isn't a structured record yet. It could mean a full-time person on a short contract, a vendor with limited access, or an agency worker who follows a specific template. To find the answer, the agent looks at the company HR policy stored in SharePoint. It uses a permission-aware search index to find the right documents and asks the manager clarifying questions to pick the right category. This whole conversation takes about 30 seconds. In the old model, this required a long email chain or a phone call, which created a massive delay before the real work even started. Once the intent is clear, the agent layer makes the routing decision. It figures out which onboarding workflow applies and which approvals are needed based on the contractor type. The agent handles these decisions by looking up policies and using context-aware reasoning. It doesn't ask a flow to figure out which branch to take. Instead, it makes a judgment call and hands the flow a structured instruction to provision a specific account type with set permissions for a fixed duration. The Power Automate flows that kick in now are intentionally narrow and specific. They handle account provisioning, license assignments from an approved list, and system notifications to IT and the hiring manager. They also route approvals through the right chain based on the access level of the contractor. These are deterministic steps with known inputs and very clear outputs. They don't need to think or reason. They just need to execute the task reliably and log every single action so the compliance team can check them later. That is exactly what a well-designed cloud flow is built to do. The Power App shows up when it is time for the structured completion step. The hiring manager gets a notification that the agent has gathered all the context and pre-filled a role-specific form. When the manager opens that form, it isn't a blank screen. It is already filled out with everything the agent collected, showing only the specific fields that need a human to confirm or adjust. The manager reviews the details, makes a quick change if necessary, and hits confirm. That one click triggers the next phase of the flow sequence. Dataverse sits underneath the entire process as the shared source of truth. Both the agent and the Power App read from and write to this exact same data model. The agent doesn't keep its own private notes that the app can't see. And the app doesn't create records in a silo that the agent can't understand. Because they share a data model, they share context. This means the system stays consistent no matter which interface the user chooses to use at any given moment. The governance layer is the thread that ties everything together. DLP policies apply to the agent's connectors and knowledge sources just like they do for flows. The same framework that controls what a flow can do also limits what the agent can find and act on. Since agent flows run under Copilot Studio capacity, the organization tracks licensing and usage at the agent level rather than hunting through individual flow entitlements. Every interaction, execution, and submission feeds into Purview. This gives the compliance team one single view of what happened and who authorized it. But here is the real insight. The complexity of the process didn't actually go away. Onboarding still has the same business rules it always had, but the big shift is where that complexity lives. In the old way of doing things, complexity was scattered across different screens, messy formulas, and manual handoffs. Now it lives in the orchestration layer. You have agent instructions that are easy to read and test, modular flows that are easy to fix, and a data model that everyone shares. Moving that complexity into governed, auditable pieces is what makes the system stay manageable as the company grows. An architect designed this entire flow. Someone had to decide which layer owned which specific responsibility. That person's logic is the only reason the whole thing actually functions. The security implications nobody is talking about. The architecture we just walked through is great when it is designed correctly, but there is a side to this shift that most teams building on Copilot Studio completely ignore until a problem forces them to look at it. By the time they realize there is a gap, the design decisions that created the risk are already running in production. Agentic workflows open up the attack surface in a way that old Canvas apps never did. This isn't because agents are less secure by nature. In fact, they can be much safer than the tools they replace if you build them the right way. The problem is that the threat model has changed, and most people working on the Power Platform were trained on a security model that just doesn't apply here anymore. It starts with the identity of the agent. Every Copilot Studio agent is a machine identity in Microsoft Entra ID with its own credentials and access policies. It isn't a human user, and it isn't a flow running under someone's delegated permissions. It is a service principal. You have to treat it with the same discipline you would use for a service principal in an Azure workload. That means you need least privilege scoping, credential rotation, and conditional access rules. If you deploy an agent without these controls, you are running a powerful identity with whatever default permissions the platform gave it, and those defaults are almost never restricted enough. The problem of over-permissioning is a very real risk. We aren't talking about a hypothetical situation when we see misconfigured agents with read access to an entire SharePoint tenant. This happens when people build too fast and forget to think about scope during the design phase. An agent that can read every document in your company can find information that the user shouldn't be able to see through the normal UI. The interface used to enforce those permissions, but the agent bypassed them because the retrieval layer wasn't filtered correctly. That retrieval layer is where the RAG exposure lives. Agents use search to find documents before they generate an answer for a user. If that search doesn't use the same permission trimming that SharePoint usually does, the agent might show content from a file the user has no business seeing. The UI that used to protect that data is gone. Now, the agent's retrieval layer is the new security boundary, and you have to configure it to respect underlying permissions because it doesn't always inherit them automatically. Prompt injection is the third big risk you need to watch out for. An agent that just answers questions is a target, but an agent that can take actions is a much bigger prize. If an agent can create records, trigger approvals, or change system settings, it becomes a major target for anyone looking to abuse those powers. Prompt injection happens when malicious instructions are hidden in the content an agent processes, causing it to do things it wasn't supposed to do. There is no equivalent for this in traditional app security. You can't SQL inject a simple gallery, but you can definitely prompt inject an agent if you don't have the right guardrails. Fixing these governance issues isn't a separate project from the architecture work. It is the same work, just with security as a main requirement. You need agent IDs managed in Entra with the smallest possible access levels. You need conditional access policies that look at the context of what the agent is doing. You also need DLP policies for every connector. Finally, you need to pipe all your audit logs into Sentinel. This way, if an agent starts touching data it has never used before or sends a massive spike of actions, you see it immediately instead of finding out after the damage is done. If an architect thinks security is a separate task for another team to handle later, they aren't really an architect. They are a liability to the company. Security isn't a gate you pass through at the end of the build. It has to be part of every single layer and every design decision we have talked about today. What junior roles actually look like now. Stack Overflow recently released data that confirms what many of us already felt. Entry-level tech hiring dropped 25% in 24. That isn't just a small dip or a rounding error, it's a structural shift in how companies value early career talent. And if you look closely at why this is happening, it tells you exactly where the entire ecosystem is headed. The roles under the most pressure right now are the ones that used to define the first 2 years of a career. Scaffolding, boilerplate, basic CRUD work, routine documentation. We used to call these the easy assignments, not because they were mindless, but because the skills were easy to learn and the cost of a mistake was low. But those tasks weren't just busy work, they were how you built judgment. You learned how systems actually behaved by building the small pieces that connected them, and you understood data models by writing the queries that pulled from them. The repetitive work was never the point, the deep understanding you gained while doing it was. Now, agentic AI is handling a massive chunk of that volume. It isn't doing all of it, and it certainly isn't doing it perfectly, but it's doing enough that the supply of hands-on repetitive tasks for new hires is drying up. The old apprenticeship model relied on a steady stream of small concrete problems where mistakes were survivable. That supply is shrinking, and what's replacing it is a different kind of work that requires a completely different starting posture. The tasks that matter now at the entry level are about judgment rather than production. It's about writing precise specifications that an agent can execute without getting confused. And it's about reviewing AI-generated logic for correctness instead of just checking if the code runs. Juniors are now being asked to inspect security boundaries and understand system architecture much earlier than previous generations ever had to, and this is the part that makes people uncomfortable. The traditional career ladder worked because you could be productive while knowing very little about the full system. Your work was scoped so narrowly that local knowledge was enough to get the job done. But this shift is compressing the learning curve whether we like it or not. A junior developer reviewing agent output needs to know what the agent was supposed to do, what it actually did, and why those two things might be different. That requires a level of architectural context that used to take years to build. The reality is that career ladders built for the old world are now producing the wrong outcomes. If the entry point used to be build these specific things, and that task is now automated, the entry point has to change. Organizations that don't redesign their onboarding are going to struggle to develop talent that can actually survive in this environment. The easy starter tasks are gone and they aren't coming back. But the judgment those tasks were meant to build still has to come from somewhere. This isn't a story about people being replaced. A generation of developers isn't being eliminated. They're being redefined. They're being asked to contribute earlier and in ways the industry hasn't quite figured out how to support yet. Is Copilot Studio actually replacing low-code developers? So let's get straight to the question that the title of this video has been holding over us. Is Copilot Studio replacing low-code developers? The honest answer is, it depends on which part of the job you're talking about. What's actually being displaced is a very specific type of practitioner. I'm talking about the manual screen builder. The person whose primary value was building Canvas apps as fast as possible. This was the PowerFX specialist who knew exactly how to wire a gallery selection into a variable or how to structure a complex patch function. That role existed because there was a massive gap between what a business user could do and what a professional dev team could deliver in 6 months. Canvas apps filled that gap perfectly, and the people who could build them were incredibly valuable. The gap is still there, but it has moved. The delivery problem is increasingly being solved by AI-assisted generation. Copilot and Power Apps can now scaffold a Canvas app from a simple conversation, and the M365 Agent Toolkit can provision a working agent from a single instruction file. The speed advantage that screen builders had over traditional developers is disappearing because of the same platform shift hitting everyone else when the tool builds the first version for you. The skill that matters isn't how fast you can click, it's how well you can design what the system should actually do. That is the part that isn't being replaced. The person who understands the business process, who can sit with a department head and find the real problem hidden under a request. That person is more valuable now than ever. The platform can generate the artifacts, but it cannot replace judgment. It can't decide which layer should own a specific decision, and it doesn't know what to do when reality doesn't match the original design. The data shows both sides of this story happening at the same time. About 78% of Power Platform teams are experimenting with Copilot Studio, yet 88% are still building Canvas apps. Those numbers aren't fighting each other. They're describing two different parts of the same modern architecture. Copilot Studio is becoming the orchestration layer that sits on top of Power Apps. It isn't a replacement for it. The organizations moving the fastest aren't choosing one tool over the other. They're designing systems where each layer does what it does best, and they need people who understand where those boundaries sit. The real shift isn't Copilot Studio instead of Power Apps. It's Copilot Studio acting as a reasoning layer that makes Power Apps better by taking away the work that screens were never meant to handle. If a developer only knows how to build screens, they are being displaced. But they aren't being replaced by a specific tool. They're being replaced by the architectural shift that the tool represents. The platform rebuilt the foundation, and if you only built on the old surface, you're going to find that surface is no longer where the value is. This isn't a personal failure, it's just a platform cycle. Every cycle produces the same result. The people tied most tightly to the old way of doing things face the most pressure to change. On the other hand, the developer who understands logic and governance is in a stronger position than they've ever been. The demand for that kind of system-level thinking is growing much faster than the supply of people who can do it. We're seeing roles pop up today that didn't even exist 2 years ago, like AI product owners and logic architecture leads. These aren't just rebranded screen builder jobs, they are high-level positions being filled by people who saw the shift coming and expanded their scope before they were forced to. The question was never really about Copilot Studio replacing developers. The real question is, which part of what you do is actually irreplaceable? The answer is the same as it's always been. It's your judgment, your context, and your ability to design a system that works when reality gets messy. That part hasn't changed, even if everything else around it has. The 3 moves that matter right now. Everything we have covered leads to one practical question. Given where the platform is and where it is heading, what do you actually do differently starting this week? You need 3 moves. This is not a 6-month training plan or a long certification roadmap. These are 3 decisions about how you approach the work already sitting on your desk. Move 1 is to stop designing in screens and start designing in layers. Every solution you work on from this point forward needs an explicit answer to one question before you build anything. You have to decide which layer owns the decision. It is not about what screens you need or how many flows the project requires. You must determine if the agent, the flow, or the data model is responsible for the reasoning that drives each step. If you cannot answer that question cleanly, your design is not finished yet. This is not about adding more documentation to your day. It is about catching a structural mistake before it gets baked into the system. A structural mistake in an agentic architecture is much harder to fix than a messy PowerFX formula ever was. Move 2 is to learn the governance model before you actually need it. The 5-phase lifecycle and the risk-tiered zoning are where authority will live in 2026. The same applies to the DLP surface that now covers agent connectors and knowledge sources. Authority will not come from how fast you deliver or how many features you pack in. It will come from your ability to design systems that the organization can trust with real data and real business processes at scale. The companies figuring out agent governance right now are writing the playbooks that everyone else will have to follow later. Architects who join those conversations today have a 2-year head start on everyone who waits for a crisis to happen. Getting fluent in this model before an incident forces the conversation is how you position yourself. You want to be the person who designed the guardrails, not the person called in to explain why they were missing. Move 3 is to build one reference architecture. I'm not talking about a tutorial project or a proof of concept that just shows off a feature. You need a real design artifact with diagrams and architecture decision records. It should include a written rationale for why every component sits in its specific layer. This artifact shows an agent, a flow, and a Canvas app working together under one shared governance model. A resume cannot carry this kind of signal, but a portfolio can. It proves that you think at the system level instead of just the screen level. This is the document you bring into a design review to show your worth. Building it once against a realistic use case forces you to make every trade-off we have discussed. It turns theoretical ideas into actual decisions. The career signals show why this is urgent. Organizations are actively posting for AI product owners and agent COE leads. These logic architecture titles did not even exist in job listings 24 months ago. The AB 900 certification for Microsoft 365 Copilot and agent administration is now a preferred qualification for many architect roles. The platform is telling you exactly what it values through the job market. The window to be early to this transition is measured in months, not years. This is not about learning a new tool. Copilot Studio is just a tool, but the shift happening underneath it is architectural. The organizations building fluency in that architecture now are creating a foundation that will grow when the next wave of capability arrives. The people who wait will simply inherit those decisions rather than making them. What you build in the next 6 months determines your path. You will either be the person who designed this layer or the person who was handed a design by someone else. Both paths are still open right now. The one you take is a choice you make in the work you are doing today. The value in low-code development has moved from the screen to the system. We are moving away from building interfaces and toward governing the logic that runs beneath them. That is the shift. Everything else we talked about in this episode is just a consequence of that change. Here is your challenge for this week. In your next project, find one place where business logic currently lives on a screen. Ask yourself if that logic belongs in an agent instruction, a flow, or a data layer rule instead. Just find one. That single question is how you start the transition. If this changed how you think about your career in the Microsoft ecosystem, please leave a review. It helps more people find this conversation. The people who need this information most are often the ones who have not found it yet. Follow me, Mirko Peters, on LinkedIn for more analysis on where this platform is actually going. I focus on the logic, not just the announcements. I will see you in the next one.